For video 2 of quadratic functions and their graphs, we're now going to move to part 2 of the same worksheet that is linked on the page with all of the other videos. So we are now going to be looking at transformations with regards to moving a parabola either left or right, and possibly up or down. And we're going to use group E and group G on this worksheet to help us kind of uncover what these additions and subtractions are going to look like once we actually graph them. So the best way to kind of learn how these transformations are occurring when we are comparing the new graph to its parent function is to study the vertex. So remember, the vertex is maybe the absolute minimum of your parabola if it is opening upward. So specifically, just to serve as a reminder, let me go into our calculator, and I would encourage you to also do the same thing. So if I go into y equals, and I type in either our parent function or our toolkit function, they do mean the same thing. If I type in x squared and graph this, our vertex is going to be this absolute minimum point. So our vertex is located at the point 0, 0. What I also want you to note is that this is where what we also call the axis of symmetry is located. And the axis of symmetry can be denoted by this dashed line that I have kind of appearing in pink on the screen. So this is essentially where we can fold the parabola, and all the points on, say, the left side of the parabola will fold neatly and lay on top of all the points on the right side. The nice thing to note is if you know where the vertex is, the x value of that coordinate point is where you can also locate where your axis of symmetry is. So let's go ahead and start investigating. So I'm going to clear out my screen, and I'm going to go back to y equals. I'm going to arrow down to my second line, and we are going to type in the function g of x, which we have noted as x minus 3. I'm going to raise that to the second power. So what I want you to note here is that the subtraction of 3 that you're seeing, this is happening inside of the function. The function itself is referring to the squaring. So notice that I do have parentheses here. So the subtraction that you're seeing, or this removal of 3, is actually referring to what's happening inside of the function. Let's go ahead and graph that. So when I subtracted 3, follow along with what happened to the vertex. So remember, we said our vertex starts at the origin. So this is where our parent function's vertex is located. But when I did x minus 3 squared, the vertex then moved and became the point 3, 0. So what happens is when I subtract 3, I'm actually moving my parabola to the right 3 units. So a quick note, when you are kind of trying to explain how things are transforming, don't just say that you moved over 3 units. You do want to include that specific direction, because I could technically move over to the left 3 units just as easily as moving over to the right 3 units. You do need to include that specific direction. So this might seem a little counterintuitive, because you might be thinking, well, I saw x minus 3, so shouldn't that mean that I moved to the left? Well, let me go back to our y equals screen. So a while back when we were studying our absolute value function, we had learned the general structure was y is equal to a times the absolute value of x minus h plus k. So from here, remember the subtraction sign was already kind of pre-installed. And when we were kind of talking about the geometric interpretation, we were talking about that the distance between x and this positive number will have that minus sign. So we can kind of take a similar look at this from the perspective of the quadratic. So we could rewrite this as y is equal to a times x minus h. And instead of those absolute value symbols, I'm going to use parentheses and write that square in there to talk about a quadratic function now, plus k. It's the same idea. The subtraction sign that you see in this general structure is pre-installed. So if I were kind of rewriting this function, I would say that this is y is equal to x minus positive 3 squared. And then I don't have a plus k, but we could say that this is plus 0. So again, the subtraction sign that you're seeing there is pre-installed. What comes after that subtraction sign is a positive 3. So this is why we move over to the right 3 units. In previous classes, what I would tell students is think of it as the house of lies. So if you don't necessarily think about the subtraction sign being pre-installed, just think when you're inside of the function, so within those parentheses, think opposite. Okay, so let's go ahead and dive a little bit deeper. Let's compare this to our next function, so our p of x. And this time our function is going to be our x minus 3 squared. And then we're going to go ahead and add 5 to it. So notice that now the 5 is being added to the outside of the function. It is not contained inside those parentheses. So let's see what happens when we graph this. Okay, so again, we did see the minus 3. So it does explain why we moved over to the right 3. And then it ended here. So it looks like it ended around here. So that means that I went 1, 2, 3, 4, 5. I went up 5. So if we were to go back to the function that we were just studying, I can call these items out. So I'm going to use a different color. So the number that appears right after the subtraction sign, this said to go to the right 3 units. And any values that you see outside being added or subtracted, they're literal. So we don't have to kind of think of the house of lies or the opposite. When we look at the plus 5 out here, this is saying I'm going to go up 5 units. So really quickly to also summarize this, note that anything inside of the function is going to be dealing with a right or left movement when you are adding or subtracting it. Anything that is being added or subtracted outside of the function or outside of those parentheses in this case, it's going to be telling you to either move up or down. Again, the numbers inside of the house, if you just look at it for face value, this is going to be the opposite. If you see a minus 3, you really want to think positive 3, so move in that positive direction or to the right. When you are outside of the function, it is literal. So if you see a positive 5, you are going to go up 5. If you see a negative 7, you are going to go down 7. So let's go ahead and take a look at our group G. So again, this one is going to look pretty similar. I just have to make a change to our third function. So we've actually already kind of discussed this. So the only thing that they have different in this situation is instead of a plus 5, we're going to use a minus 5. And again, if I let the cursor fall on top of the plus sign and write the minus sign, it will overwrite it. So again, the minus 5 that we're looking at is happening outside of the function or outside of those parentheses. So when I graph, let's see what happens. There's our second function, and then our third function is located here. So again, let's use our vertex to help us. So note that the vertex is located here. Let me actually draw that in. And that looks like it is happening at an x value of 3 and a y value of -5. So again, we can see that this information was present to us in the function that we were working with. We saw the x minus 3 followed by the minus 5. Also, again, note that our axis of symmetry is happening at x is equal to 3. If I go to this part of the line and fold it along this purple line here, I have everything nice and symmetric. So really quickly before we wrap up this video, I also wanted to, because I have been talking about it, what does it look like if we were moving everything to the left instead? So I'm going to go ahead and just work with the second line that we have there. I'm going to clear out my third one so that I don't have too much going on my screen. And so what happens if you are working with a function and instead of an x minus 3, maybe you have like an x plus, let's do 6. I'm just choosing that just to choose it. So if we go ahead and graph this, let's see what happens to the parabola and specifically follow where the vertex goes. So again, if we are looking at this problem, remember our vertex on our parent function always starts at the origin. And then when we did x plus 6 on the inside of the function, we now had something, we now have a vertex that starts at -6, 0. So when you are working with that function, so y is equal to x plus 6 squared, you could think, okay, it's inside the function, house of lies, instead of the +6, I should think -6. The other way to think of this would be to rewrite this. Remember that it comes with a pre-installed minus sign, so if I have a +6 here, I could rewrite this as x minus -6 squared. You will also see that that's how you can identify that you should move to the left 6 units. All right, we are going to move to another video, specifically graphing by hand instead of using the calculator.